This is our new product line, the Discovery Series. This is the D152. D is for Discovery, 15 metric ton, 2 stands for 4x2. There is a second model that we'll be coming out with in January, which is a D154, 15 metric ton with a 4x4 chassis. This particular machine comes in at about 31,000 pounds. So it's under the 33,000 pound FET requirement, which is a big deal. And right now we believe the D154 will also be under 33,000 pounds and avoid the FET as well. Big deal. So it saves a lot of money for the people buying the machines. As far as the individual components themselves, this is a Freightliner M2 chassis. It is a very specific Gradall spec M2. So it's got heavy-duty frame and liners end to end on the chassis, and it's also got heavy-duty reinforcing braces end to end that we've worked with Freightliner on. So the standard bracing wasn't good enough for an excavator to be mounted to the chassis. We had to sit down with them and look at exactly what forces we were going to put into the chassis so the chassis can survive. It's a big deal. Most bodybuilders, they put a load on the chassis. We don't. We have a working excavator on the chassis, and it works off corners. And when you work off corners, you twist that frame. You twist it very hard. So you've got to take that into account. So this thing right here has the extra frame liner end to end with all the reinforcing braces, and then we lay a torque box on the frame. The goal of that torque box is to dissipate that torque rear to front, so that when we transition over to the frame itself, you don't have anything abrupt happening with the chassis. It's a very serious consideration that most bodybuilders don't have to take into account. As far as the chassis itself goes, it's got all the normal Freightliner features. It's got AC, it's got heat, it's got radio, it's got cruise control, it's got the fully adjustable seat, the ergonomic cab, good visibility, all that good stuff. And the M2 chassis is the #1 chassis sold in North America today. Freightliner is anticipating they're going to build somewhere in the vicinity of 45,000 next year. So this is a commodity. It's something that is very well accepted in the marketplace right now. Cummins 6.7 liter engine, rated for 220 horsepower. I think it's somewhere around 570 foot-pounds of torque. I don't know the exact number, but it's something like that, which is plenty adequate for this machine. You can also have a passenger, a flagman, whatever you want in there, which does come up. Someone's got to get out there to help the operator, especially where we're at alongside a road. As far as the fuel tank goes, 80-gallon fuel tank, 13-gallon DEF tank. This does require DEF. This is an over-highway truck. So in order to comply with over-highway EPA regulations, you have to run EPA. It's the way everything's going. There's no avoiding at this point. Right here we have of course, the boom rest, but we integrated into the boom rest the hydraulic reservoir and the hydraulic oil cooler. So it's all built into the torque box assembly. And when we buy this chassis, it comes from Freightliner with a power takeoff of our choice that we've been using on the XL series for a long time. It's the same PTO. And the pump basically gets mounted at Gradall, and it gets plumbed over to a swivel for oil to go to the upper. As far as modifications to the chassis itself that we make, we don't make a lot. The drivetrain itself is not altered. We don't do anything with it. Other than we add a steering cylinder to the front, so you can steer from the upper structure, and the upper structure steering is electronic. So in the past, we always had a foot pedal down there. We moved that up to the joystick to make room for the brake pedal, which I'll talk about in a second. So we add a steering cylinder and we add lockout valves. The lockout valves are these red cylinders right there. Those red cylinders lock when you're operating the excavator so that the front axle doesn't move. It basically keeps the machine more stable. Moving to the back of the chassis, we actually removed the stock rear suspension from Freightliner, the leaf springs, and we hard mount the rear axle directly to the frame and our torque box. We do it for stability when operating from the upper structure. If you put something down here and it moves around, then you're going to have to add another set of lock cylinders. We didn't think that was a good idea. This is how we handle the rear axle on all of our other highway speeds. One big change on this machine, there's a number of big ones, but one big change is in the upper structure. Gradalls up to this point, when we're talking about the remote drive capability, they were hydraulically driven in remote. So you had an accelerator pedal, which you have here, and no brake. You would step on the accelerator pedal, and oil would transfer down to a transfer case, which we would add to the chassis, and it would turn a hydraulic motor and it would drive it forward and back. But with the advent of these new sophisticated transmissions, electronic controls, and all that good stuff, we have an electronic control from that pedal through a processor that runs down to the Allison. And what we're actually doing is engaging the Allison first gear electronically. So you don't require two separate drive systems to maneuver the machine from the upper and from the chassis. It's essentially the same as driving it from here, from the chassis cab or the upper cab. You're basically using the Allison. Reduces a lot of componentry. It also keeps costs down. You don't have a transfer case, you don't have to break the drive line, all the extra components, counterbalance valves, hydraulic motors, you know, an extra large center pin, extra valving. It's a big time cost saving. One of the primary reasons this is as inexpensive as it is. Having said that, when you drive this machine from the upper structure, it's very much like driving it from a chassis cab. You have to put your foot on this brake, and that is an air brake. It is tied directly into the air brake system on the chassis cab. It feels like it. You know, if you run it, and I think you said you run it, it's going to have the same feel. So you step on that brake and go push forward or reverse on the propel pedal, and you'll hear the engine RPM come down automatically, and it'll engage first gear, and you let off of the brake and step into the accelerator, and it'll drive forward and back. It does have a different feel from our hydraulic drive of the past, but it's one of those deals where if you want to, you want to reduce components, use highly reliable components and taking advantage of electronics to get costs down, it's the way to go. As far as the actual cab itself, this cab is our standard cab that we use on all the XL series. It carries over. And we do have a version of this cab that will eventually make it to North America that is already certified for ROPS FOPS. We just haven't offered it, it's not required yet, but it's coming. So we're prepared for that. As far as the cab seat and the joysticks, they're the same. They're the exact same that we use on the XL series today. We have got a new monitor that we're using with some, it does all the same basic stuff that we did in the XL series, other than it's all integrated into a monitor now instead of individual switching. So, another area where we've simplified the machine and taken a lot of the stuff out of the armrests and all the switches and all that stuff, and we've moved it all into that monitor. So you've got one electronic monitor, very easy to update. We can change the programming on it. It's just modern stuff. Pretty nice. Everything else in the upper cab is the same. This machine comes standard with AC and heat in the upper. The boom itself, if you look at the boom, that is the same boom design as we use across the entire XL series. What we've done is we've lightened it, we've made it a little shorter, and pretty much retained all of the operational characteristics that everyone's used to on a Gradall. Attachment out at the front of the machine, the attachments are pin-on. That bucket is pin-on. The attachments right now are somewhat limited. We've got a 36-inch ditching bucket, a 60-inch ditching bucket, with or without a bolt-on cutting edge, a grapple, a limb shear, and we're going to be offering auxiliary hydraulics to the end of the boom. And we'll have a Tiger 50-inch rotary mower or a 40-inch Tiger flail mower. And we wanted to have as little tail swing as we could make. So this particular machine, from the center line of the bearing out to here, has a tail swing that's 6 foot 8 inches. And it's by far the smallest amount of tail swing we've had on a Gradall. The benefit to that tail swing is when you're working alongside a road, like many Gradalls do, and you swing 90 degrees to the chassis, you don't take up any more of the road than you have to. There's a big difference between shutting down a partial lane or one lane of traffic while you're doing work down the side of a road, or blocking off into the second lane and you got to shut the road down or route off the road. So by going with as little tail swing as possible, you know, we've basically made it a one lane or less machine when you're working on an active road. You know, you need a flagman and you can get people around it a lot easier.